All right, hello everyone. This is Matt Woods again. We're going to look at shifting in this video. So shifting relates to how the graph of a base function moves. And what that means is we're going to actually move it on the coordinate axis. Another word for this you might hear, whoops, it's a transformation. So let's first talk about what a base function is. A base function is anything that just has an x and one operation in it. So x squared, absolute value of x, square root x, sine x. All these are base functions because it's just one operation applied directly to the x. So there are going to be three types of transformations. We're going to start with a horizontal shift. And when you see shift specifically, we're talking about plus minus, meaning that, excuse me, we're taking a graph and moving it either up, down, left, right. So horizontal shift is when plus minus occurs inside the operation. So for example, if I have f of x equals x squared, and I translate that into x minus 5 squared, this is where the minus sign is on the inside of the parentheses. The operation applies to the plus or minus. So how do I know which way this shifts, horizontal or left or right, I mean, compared to the base graph? Well, now this is where you're going to have to forgive my skills of an artist, because I'm not that good at drawing. As you can see there, I'm not that good at drawing. So this is not going to come out to scale by any stretch of the imagination. I'm going to do my best. But remember that y equals x squared looks something like this. You got your basic parabola. And now let's see. We're going to make our own XY table to figure out how this thing moves. And I'm going to, since 5 is involved as my shift, 5 down here, negative 5 up here. And see, I'm not that good at drawing, so let me get my eraser out. Oops. And we'll go one beyond that there. Now I'm only going to write in the work for the first one of these, because just for time's sake. But when you're doing this, you should take the time to fill out each and every one of these. It looks like a lot, but you're going to have a much sharper idea of how this thing's going to look. So negative 5 minus 5 squared. Well, negative 5 minus 5 is negative 10. Squared would be 100. Negative 4 minus 5 would be negative 9, so that'd be 81. This one's going to be 64. -2 would be -7 squared, 49, -6 squared, 36, -5 squared, 25. 5 is -4 squared, so that's 16. I know, again, I'm sorry, I'm a really terrible drawer, and it's really tough to make a table freehand on Zoom. 2 minus 5 is -3, squared is 9. 4 minus 5, that's -1, squared is 1. 5 minus 5, that's 0. And then 6 minus 5 is 1. So you can see it's starting to come back up. So my 0 is over here at x equals 5, and it's going up like that. So this is x minus 5. So now we know how this is supposed to look. We see how it's shifted, and you can see that it's shifted right 5 units. So anytime that it's a minus inside of your operation, you actually shift to the right. It looks like you're supposed to shift to the left because that's where the negative numbers are. But what actually is happening is you're shifting to the right. You can see that because what it does is it shifts where this occurs. So instead of 0 occurring at the origin at x equals 0, your 0 of your function, remember from factoring in your roots, 0 of the function now happens at x equals 5. So everything shifts according to that. That means that to go from f of x up equals x squared to f of x being x plus 5 squared, now you're going to be shifted over to here. And I should have drawn it better on this one. They should be the same size. We're not magnifying anything yet. That'll be the last thing we cover in this one. So you can see they shift based off of where the 0 becomes. And this idea will work for any type of function that you have. So for example, if I switch to an absolute value function, going to absolute value of x plus 2, we'd expect that the absolute value function, remember it's the v, that looks like this, we shifted over to here. Does that happen? This one's going to be a much smaller one to do. -3, -2, -1, 0, 1, 2, 3. -3 plus 2, that's -1. So absolute value of that is 1. -2 plus 2 is 0. -1 plus 2 is positive 1. 0 plus 2, that's 2, 3, 4, 5. So now we see our 0 has moved to here. So yes, it shifts just like we thought it would. Here's the absolute value of x. Here's the absolute value of x plus 2. Okay, so horizontal shifts, if it's x plus some number, shift left. A units. I'm going to put them in parentheses to indicate whatever operation you're doing. If it's absolute value, if it's sign, if it's an exponent, it's not going to matter because it's on the inside of whatever that operation is. And x minus a is shift right. A's. And remember, you can always throw together your own XY table and plot it for yourself and find out that way. Now, the much easier one to understand are vertical shifts. So a vertical shift happens when the plus and minus is outside the operation. So for example, if we go back to our absolute value function, going to absolute value of x plus 3. So you see here how the plus is not being the function, the operation does not apply to the plus minus. So which way does this shift? Well, remember, got our absolute value function. Let me see if I can draw that a slightly bit better. That'll do. And we're doing absolute value of x plus 3. So we have so that's at 3. So I'm going to do -4, -3, -2, -1, 0, 1, 2, 3, 4. Since I'm expecting 3 to be the important point here, I'm going to go on multiple sides on both sides of 3. And I just realized that this is not the function. That is. So absolute value of -4 is 4 plus 3, that's 7. Absolute value of -3 is 3 plus 3 is 6. So 2 plus 3, that's 5. -1, so that's 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3, 5. 3 plus 3, 6. 7. Okay. So now when x is 0, y is 3. So I'm going to pull this to here. I have that. So always look for either where your x is 0, or if it does, or if that never occurs, where your y is 0. And notice in this case, we never have a y being 0, so we have to shift it where x is 0. So this was plus 3, it shifted up 3 units. And what do you, and just what you think would happen here becomes this. You shift down. The last thing that we're going to do in this video is magnification. So magnification occurs when you multiply. A function. So if we go from, let me keep using function notation. There we go. absolute value of x to the absolute value of 3x. Does it get wider or narrower? And the reason why I'm asking it that way is because when the placement comes around, most of the questions where you'll see this specific part of transformations and shifting is when you'll have to pick out the graph of the function. And since you can't use a graphing calculator, this is a good way for you to think about it. Well, let's see. So I'm actually going to run two tables concurrently for this one. And we're going to go -2, -1, 0, 1, 2. Absolute value of -2 is 2. Now the absolute value of 3 times -2 is 6. Absolute value of -1 times 3 is 3. Here I got 1. I get 0 for both of these. 1, 2. Over here, 3 times 1 is 3. 3 times 2 is 6. So this one's happening much faster. So when you look at the graph, here's your base function. Now if 1 is here, 1's actually here. Your magnified function. This is absolute value of 3x. This is absolute value of x. You can see that it narrows. And that's because this change occurs quicker the slopes get steeper. So when you multiply a function like the absolute value graph, it's actually going to look like it's shrinking. But the thing is, the changes that are happening between x values are occurring much faster. So that's why it looks like it's shrinking, but it's actually going a lot quicker. Now, of course, the opposite is true if you divide. So if you have, there's your absolute value of x. This would be the absolute value of x over 3. Because now the change occurs slower. So when it's a fraction, it changes slower. The lines, and I shouldn't say the lines, I should say the slopes, are gentler. I'm not sure if that's a word, you have to ask the writing center. So that's the whole point between shifting and magnification. So again, with the placement, most of the time where you'll see these is you'll get a question like which of these looks like the graph of f of x equals absolute value of x plus 2. And then you'll have to pick the picture that matches that. So you can do the XY tables like I showed you before, or if you know the shifting rules like we just talked about, you'll be in a really good spot. So that's it for this video, and I'll see you in another one. See ya.